So, Dean, you were asking a question. Can you just please repeat it? You were asking if we are producing here a hole. I don't know if this was your question. Okay. Look, what is happening here? Always when you do blanking or punching operations, you have a hole. Okay. But the difference is that if the cut part is the desired one, then it is a blanking operation. Or if the part with the hole is the desired one, then it is a punching operation. To produce this geometry, you can do it in two ways. You can do a blanking operation or you can do a punching operation. But here they specified that we are using a blanking operation. What will be the difference? If they tell you how to produce this part using punching operation, then you will say that the initial work part, let's say this is the initial work part, then the hole here, you want to produce this hole, a rectangular hole in it. This will impose for you the punch size. Okay, so the punch size then will be equal to the dimensions of this hole, and then the die size should be like this, should be bigger. Okay, you should take a clearance from the punch for to have the die. So this will be the punch and die if you want to produce this part in case of punching operation. But since they said we should use a blanking operation, this means that the part that is cut from the operation will be the final part. In this case, the die should have the same dimension of the final work part, and the punch will be different. And the punch, in this case, your hole that you will produce, if you want, will be in the form of your final part, because you desire to take the part that is cut from the operation, not the part that will remain after cutting, after removing a certain part. Okay? Did you understand the difference between the two? So this will be, in this case, in blanking operation, this will be your punch. Okay. Now, so we have determined together then the different dimensions. So here they are just repeating what we did. They calculated the clearance. For the length of 85, it will become 85 minus 2 times 0.3. For the 50 millimeter width dimension, also it will be 50 minus 2 times 0.3. And for top and bottom extensions of 25 millimeters, it will be 25 minus 2 times 0.3. Now, just for the two 25 millimeter in set dimensions, they will remain the same as we have demonstrated in the figure. Okay? Now, determine the minimum force capacity press to perform the blanking and punching operation in problem 16.2 under the following condition. So in problem 16.2, if you remember, we had, we will go back to it, okay? We want to determine what will be the capacity of the press in case blanking and punching occur simultaneously at the same time, or if the punches are staggered, so that punching occurs first, then blanking. Okay, so let us go back to the figure in 16.2. So if you remember, our purpose was to produce this part. Okay, now when you want to produce such part, okay, you have that you can do it in several ways. First, you can do it by doing blanking and punching. So first we do the blanking, as we said, to obtain the outer cylinder, and then we do a punching operation to produce a hole inside. Now, we can do blanking then punching, or we can do punching then blanking, or we can do both at the same time. What will be the difference? The difference will be the capacity of the press used, because if you want to do simultaneously punching and blanking operations, you will need a higher force. Because how to determine the cutting force required? The cutting force required, F, is equal to the shear strength of your metal times the area of shear, which is the thickness, times the total cut length. Okay. Now, if you perform both operation at the same time, blanking and punching, then the total length will be higher because it will be equal to the length of a blanking operation plus the length of punching operation. Now, what is the cutting length for the blanking operation? In the blanking operation, you are producing the outer cylinder. So the perimeter, which is the length of cut, will be equal to the perimeter of the outer cylinder. So L blanking is pi times d outer. While when performing the punching operation, the length of cut is the perimeter of the hole, which is, so L punching will be pi times d inner. Okay, so if you want to perform both at the same time, then the total cutting length will be the summation of pi d outer plus pi d inner. Okay, now the second step, in case I want to find what will be the press capacity if I do the two processes not at the same time. Who will tell me? Who will impose the press capacity? The blanking operation or the punching operation? So if they are not done at the same time, which one is more critical? Which one require a higher force? Yes, very good. The blanking. Why? Because you have the strength, shear strength is the same for both operations because it's the same metal. And the thickness also is the same. Okay. So we just have that the force will be equal to S times T times L. So higher the cut length, higher the force. The force is proportional to the cut length. And these two are common between the two processes. So to compare the forces, then the higher force will be for the higher cut length. And of course, since the outer diameter is larger than the inner diameter, then L blanking will be higher than L punching. So if the two processes are done separately, then we will design our press based on the length in cutoff length in blanking operation. Okay, so here, so first, of course, we need to determine, we already determined what is the value of the clearance, okay, from the previous problem. And concerning the shear strength, they gave us the tensile strength. So we should multiply it by 0.7 to get the value of the shear strength, okay? And then we can write that the force is given by 0.7, the tensile strength times T times L. Concerning the first question A, we are doing the two operations at the same time. This is why the total cut length will be equal to the length of blanking plus the length of punching. And then this will give us the total length of cut. Then replacing, we can get the capacity of the press required. So here, of course, it will be a capacity higher than in the case we are doing the two operations separately. So when we do the two operations separately, since the length of cut for the blanking operation is higher, it will determine the minimum tonnage press required. So then we will use L equal to 25 pi, and the force F will be given by S times 25 pi times the thickness. So we get that the press capacity in this case should be 61 point something Newton, while it was much higher in case of doing the two operations at the same time. It was 91 kilonewton. Okay. Can I just take from your time 5 more minutes to finish this problem? Okay. You have a problem, just 5 minutes. Okay. So just in problem 15.5, we want to determine the tonnage requirement for the blanking operation in the problem 16.3. So we have already done problem 16.3. We have calculated the clearance, okay, and we know the dimensions here. What are the dimensions of the die? Just the one thing, for when you calculate the cut length, it's not required to, the clearance effect can be neglected. Okay, so here, since it's a blanking operation, you consider that the cutting length is equal to the dimensions here, so no need to take into account the clearance effect. So the total cut length in this problem is simply the perimeter of this shape. Okay, so it is 85 plus, since I have symmetry, it's 2 times 50 plus 2 times 25. So 2 times 25 for this side, and 2 times 25 for this side, and plus 35. So in this way, I can calculate the total perimeter, which represents the cut length in the blanking operation. Then, once I obtain it, all I have to do is to multiply by the thickness and by the value of the shear strength. Now, just one remark. When they give you uh, all properties, and here you have yield strength, you have shear strength, and you have tensile strength, don't use in this case the approximation 0.7 times 650, because it's an approximation. So if I know the actual value, why I want to do the approximation? Okay, so here you will just directly use the shear strength given, which is 450 megapascal. So now, by replacing in your formula, you have the shear strength is 450. The total length is provided from the perimeter of the part that is cut from the operation, and you have that the thickness is given in the problem as 4 millimeter. So just for units, pay attention for units. If your force should be in Newton, since the shear strength is provided in megapascal, then I will use the dimensions in millimeter, because megapascal is 10 minus 6, 10 to the power 6 Pascal. And millimeter square here, when I do millimeter times millimeter, it's millimeter square, so it's 10 minus 6 meter square. So when you multiply megapascal by millimeter square, you will get the unit, the final unit in Newton, which is Pascal meter square. Okay? Any question on this?
Yes دكتور. يعني
Yes.
دايما إذا بنجيب الفورس ما بنحسب الكليرنس.
لا، بالفورس ما بنحسب الكليرنس، بنحسب الفاينل، يعني الكت بارت. what is the length of the cut part. Okay, we multiply it by the thickness and the shear strength. We don't take into، يعني the effect of clearance is negligible. Okay, لأنه أصلا if you take into account the clearance حتكون هي الكليرنس is very small compared to the total length، فما حتأثر. This is why we consider إنه we take the total length of the desired part as my length of cut. Okay, in a blanking or punching operation ما بتفرق. Okay, any other question on this? So see you next time. Bye bye.
باي دكتور.